Hi everybody, and welcome to the next video of my series about my newest game, Battle for Antares, which I'm going to release on Steam quite soon. In this series, I would like to show you the whole game, all the components which make up the game, how everything works together, and how this stuff works under the hood internally. Probably that is of interest to you when you are also doing some game development, or whether you want to learn how certain things work. So I hope that is interesting for you. In this particular video, I would like to discuss with you this rally point, which is used to order around your drones within the galaxy. You can order these drones to stars in order to invade them, or you can even order them to your opponent's star systems to fight against them. And of course, the goal of this game is to overwhelm your opponent, crush his army, and then eventually defeat him. And in order to do so, you need this rally point to make your choices where your army should move to. And like I said, today I would like to discuss how that works internally, at least parts of the logic. Probably not everything, but parts of it. So the rally point itself is another actor in the game, and it is essentially composed of these three planes. So I have these XY plane, this YZ plane, and the XZ plane. All of them share the same texture, this player rally material, which is just an instance of this particular material. And this material essentially uses this texture here. It essentially uses this texture here, which I have created, and then uses this rotator to make it essentially rotate all the time. So with this speed, for example, I could adjust the speed with which it rotates. And it is also using the total game time and putting that through a sine function, and then mapping that in a certain range, multiplying everything with this color here to give this nice pulsating effect. So if I would multiply this now, or if I would essentially multiply this before I put it into the sine function with a certain value, then it would pulsate much quicker. So that's pretty much how this works here. This effect works. And now when you want to move around this rally point, essentially you need to right click in space, and this logic happens again within the camera controller. So there's this input action event move rally point, and when you press the right mouse button, then this event is called. And what happens here is essentially I'm taking the mouse position, the current mouse position, and I'm deprojecting that into the world. So it's this 2D position of where you've clicked is projected into a ray within the world using the current camera orientation and location. This essentially gives me 1 point on the near plane of the camera and the direction in which this ray is facing. And now essentially I just need to calculate where this ray intersects with the ground plane, so where the Z coordinate of that ray is 0. That's essentially because all the stars are located on this ground plane with that Z coordinate 0. So essentially I just need to calculate that point where that Z coordinate is 0. So there's some basic arithmetic happening here, some basic geometry here to calculate that. And of course it could happen that depending on the camera position and the orientation and where you click, it could happen that this point is then outside of the playable area. And in order to, and then I constrain that here to make sure that I only have reasonable positions where the player can order his fleet to. And now eventually this goes into this move rally point function, which in this particular case is just a helper function, which helps me to, on the first call, set up this rally point. So if the rally point is not valid, then essentially I'm spawning one at this location. And this only happens at the very first call. All the other calls directly call the respective move function of the rally point. So all the magic really happens in here. And essentially, the very first thing I'm doing is to check whether there's actually some kind of substantial movement, because there is some logic here dealing with drones and invading stars and stuff, which I don't want to trigger all the time when you only do like minor changes, when you do not really move your rally point away, like you're only clicking 10 times with the right mouse button on the same location. Then I don't want this logic to be executed all the time. So there's this minimum distance which I expect these points to be moved, and only if that's the case, then of course I'm setting the new actor location, so I'm moving the actor to that new location. But I also need to run a couple of game logic on while that's happening. The first thing I need to do is I need to check out all the drones. There's this, I'm going to discuss that in more detail later, but there's this drone check in, check out mechanism where drones essentially check into the rally point when they reach them, and where they check out of the rally point when they move away from it. So that I always have this complete list of all the drones at the rally point, which makes this fighting logic, the gameplay logic about drones combating each other easier. You would see that in some other videos. But essentially, since I moved the rally point, I need to check out all the drones. And now what I need to do is I need to check whether you have moved your rally point close to your opponent's rally point. The same function, by the way, is also called from the artificial intelligence if it wants to move its rally point. So here, essentially, I'm just checking whether the new position is very close to the other rally point. And if that's the case, I remember that there is no combat now, and I also let all the rally points know that now there is combat. So I'm calling this toggle combat function. We can go into that a bit later here. But what also happens is that I iterate through all the stars. I'm getting all the solar systems in the game and iterating through them and see if there is a star close by. So for each of these, I get the location and the distance to the new rally point location, and see essentially I'm finding the nearest star, and if that star is closer than a certain distance, then I am marking that as my rallied star. So this is now all the drones are rallied to that star. And this logic is then used to decide whether we are repairing our drones, if I own the star, or whether we are invading it, or these kind of things, and whether the star is defending. If it's owned by your opponent, then the planets itself start shooting at your drone. So this kind of logic is settled then here. And eventually there's also this event dispatcher, which announces that we have moved the rally point to the whole game. So there are a couple of other components which listen on this event dispatcher because they need to adjust their respective logic. So there's this event where we just announce that something happened. Okay, let us quickly look into this toggle combat function. Essentially, this toggle combat function for each rally point just remembers whether there is currently combat or not. And if that changes, so if there's a transition from combat to non-combat or from non-combat to combat, then there is some additional logic happen. On the one hand, I need to update this combat progress widget in the top bar, which sometimes slides down or up to indicate your fleet strength and stuff. And I also need to inform all the drones which are currently registered at this rally point and tell them that there is combat. So just imagine that you don't move your rally point, all your drones are checked in, but the AI now starts an attack on you, so it moves his rally point to yours. Then I need to inform all your drones, all the drones of the player, that now there is combat, that they should look out for that and look for targets and stuff. So these kind of things, right? So that's happening in here. And the last thing is this rallied star. So here essentially I'm just, when I change the rallied star, then essentially I'm just looking whether I previously had one star which I was rallied to, and if so, then I end the respective invasion. So this is now happening within the star system, and essentially I'm ending the invasion by just setting the respective rally point to each star has these two references to the rally points that could invade them, and if most of the time they are set to nothing, so I know that there's no invasion happening. But if so, then I just set these variables so I know that they are being invaded, and then I can later check the respective invasion strength and see how much update I need to do for each for the Serenity. And now once I have told the old star that there's no invasion anymore, I need to tell the new star that there is an invasion. So essentially I'm just setting the respective invasion player and invasion enemy variable again for these stars to remember. And then during the tick function, I can check whether there is an actual invasion happening and then update the Serenity. That's probably the scope of another video, and that should be enough for now. If there is something more which interests you, some additional questions you have, something more you would like to learn about, just let me know, shoot me a message. I'm sure I can focus some videos on your questions. So until then, thank you very much for your attention, and then see you next time. Goodbye.